Hello, in this video we're going to take a look at finding the inverse of a function, and then we're going to check our answer and graph that. Alright, so f of x is equal to x cubed plus 6. Whenever we find inverses, our first step is always to replace our f of x with a y. And so instead of f of x equals x cubed plus 6, we're going to get y equals. And then switch our x and our y. So we're going to switch and write it as x equals y cubed plus 6. Now we want to solve for y. When we solve this for y, we're going to subtract 6. And then to get rid of that cube, we're going to take the cube root of both sides, and we get y is equal to the cube root of x minus 6. And we can check that by one of two ways. We can plug in our cube root of x minus 6 in for our x on our f of x function, so plug our answer into our original and vice versa. Or we can look at the graph and see that they're the mirror image. We're going to be using to check our answer, let's go ahead and plug in and do it analytically. So if we check, we want to make sure that x cube root, we're going to take all of this and plug it in for our x here. And so that's going to be the cube root of x minus 6 quantity cubed plus 6. That's going to simplify to just x minus 6 inside the parentheses plus 6, which is x, and that works out. And then now we're going to go the other direction. So we're going to plug our original function in for just our x here. And that's going to be the cube root of, instead of just x, it's going to be x cubed plus 6. We still have that minus 6. Inside the cube root, it simplifies to x cubed. And the cube root of x cubed is equal to x. And so that is going to give us, that is checking it. And then we're going to find the domain and range of both functions. Well, the domain of f, since this is a polynomial, that means it is going to be all real numbers. And the domain of f inverse, well, this is a cube root, not a square root, so there's no restrictions on what can be underneath that radical. Remember, it's only restrictions if that is a square root or an even index root, and so it is also all real numbers. And what's always going to happen here is the range is going to be flipped, because remember we switched our x and our y's here, so we're just going to switch these. That's also going to be whatever the domain of f is will also be the range of f inverse, and vice versa. Alright, if we sketch the graph of this, x cubed plus 6 is going to have a y-intercept here at 6. And the cubic function is going to go up on the right and down on the left. That's going to be our f of x. That was our original function. And then our cube root, well, that minus 6 in there means that we are going to have a horizontal shift to the right 6. And then our cube root function is going to go up and up to the right, down to the left. And what we should see is that we get the mirror image across the line, y equal x. All right, let's do the same thing for the function f of x equals x squared minus 4. Here we have this x greater than 0 here on the end. What that is doing is just ensuring that we are looking at a one-to-one function. Because a parabola is not going to pass a horizontal line test. It's not going to be one-to-one unless we restrict that domain. So I'm actually going to draw the graph of this one first, just so we can see why we need that. So x squared minus 4, that would normally be a parabola that has a y-intercept at -4 and then opens up. But x greater than or equal to 0 is telling us we just have that right side. So our f of x is just going to be that right side. As far as our problem goes, it doesn't really impact the problem too much. So f of x becomes y. And then we're going to switch our x and our y. So we get x equals y squared minus 4. Solving this for y, we're going to add 4 to both sides. And then we want to take the square root. Well, normally we would have plus or minus here. But because of this, when we switched it, we're going to have y greater than or equal to 0, means we only want the positive one. So it's going to be the square root of x plus 4 is equal to y. So that's going to be our inverse function. And if we are to graph that, that's going to be the square root function shifted to the left 4. So we're going to have a horizontal shift, left 4, and then our square root function. And again, we see that those two graphs are symmetric across the line, y equal x. The domain of f is actually given to us in the problem. Our domain of f is going to be from 0 to infinity. And our domain of f inverse, we need what is inside that square root needs to be greater than or equal to 0. So x plus 4 needs to be greater than or equal to 0. So that means x needs to be greater than or equal to -4. So we get -4 to infinity. And we do see, like we saw in the other one, the range of f inverse. On our f inverse, the red graph here, our range is going to be from 0 to infinity. And on our original function, f of x, the blue graph here, then our range starts at -4 and goes to infinity. All right, let's look at one more. Here we have f of x equals 5x plus 6 over 4x minus 5. So the first thing we're going to do is switch out our f of x and replace it with y. And then switch our x and y. So we get x equals 5y plus 6 over 4y minus 5. We've got two y's here. One's in the numerator, one's in the denominator. So we need to get them both in the numerator. So to do that, let's multiply both sides by that denominator. When we do that on the left, we can distribute our x and we get 4xy minus 5x. On the right hand side, that denominator completely cancels out and we're only left with the numerator 5y plus 6. We want to solve this for y, so let's get all of our y's on one side. So 4xy, and then I'm going to subtract 5y to move it over. And then I want to subtract the 5x, or sorry, add the 5x to both sides to move it over. So we just want to get all of our x's on one side and anything that doesn't have an x on the other. We can factor a y out on the right hand side. Our greatest common factor there is a y. We factor that out. We are left with 4x minus 5. And then on our right, we get 6 plus 5x. And then our last step to get that y by itself is to divide by the parentheses there, 4x minus 5. That is our inverse function. if we look at the graph of this, our original function, 5x plus 6 over 4x minus 5, that's going to have a vertical asymptote where that denominator is equal to 0. So 4x minus 5 is equal to 0, or x is equal to 5 over 4. So we're going to get a vertical asymptote at x equal 5 over 4. We'll get our horizontal asymptote. Since the degrees are the same, our horizontal asymptote is also going to be 5 over 4. This is going to have a y-intercept. When x is equal to 0, our y-intercept is going to be 6 over negative 5. So that's going to be a little bit below negative 1. I don't want that in. I want to leave that in blue. Negative 6 over 5. And we get an x-intercept when our numerator is equal to 0, and that's also going to be at negative 6 over 5. And so you could also use your calculator to help you graph this. We don't have any x-intercepts or any y-intercepts, so there's no way that our graph can be down below on the right, or we can't pass a vertical line test if it's on the top on the left. So the rest of our graph has to be in the top right-hand corner. Now, this one, I wrote it in a different order, but notice how that inverse function really is the same thing as 5x plus 6 over 4x minus 5. This is one of the very few functions that actually its inverse is itself. So we're going to get the exact same graph for our inverse function. And it's going to be completely symmetrical across the line y equal x. All right, domain of our original, it's going to be everything except for the 0.54. So negative infinity to 5/4, union 5/4 to infinity, and that will also be the range of f inverse. And the domain of f inverse, it's the same function, so we get the same domain, and we get the same range. All right, I'll see you guys next time.